Hello and welcome everyone to this webinar, 3D to 2D, how to make better patterns faster using Peel CAD with ExactFlat. We're excited to have you here with us today to learn about how to use a Peel CAD scanner along with ExactFlat software that lets you convert 3D shapes to 2D surfaces. My name is Gabrielle Williams, Sales Applications Engineer for Peel USA, and I'm joined today by Gonzalo Schechter and Eaton Donald from the ExactFlat team. We also have on the call Mark Jewell, so he can assist us with providing any answers to any questions that you guys might have at the end. And they're also going to be guiding us through the steps that we'll need to convert 3D to 2D patterns. But speaking of those questions, I would like you to get a little bit more familiar with your webinar screen here. You do have something at the top with a little question mark icon. So if you just go ahead and click there, you'll be able to see where you can add questions, and we'll be sure to answer those at the end. Of course, if we run out of time, we'll be able to answer you through email. So be sure to just ask what you can, and feel free, no reservations, ask whatever you'd like. All right, and then so just for your information, we're also going to be recording this webinar, so you can watch it at a later date. But without further ado, I would like to share a little video that the team over at ExactFlat has prepared for us. So yeah, here we go.
Hello, and welcome to today's webinar on how to make better patterns faster using 3D scan to pattern. This webinar is brought to you by Peel 3D and ExactFlat. And the webinar will be presented in sections. First, we'll talk briefly about what scan to pattern is and what kinds of products it is applicable to. Next, we'll cover what's in the tool set and what's new. After that, we'll show you the workflow. Lastly, we'll answer any questions and talk about how you might get started. So first, let's get to the question, what is scan to pattern? Well, scan to pattern is simply a process for making patterns. It's faster, more accurate, and more scalable than traditional hand pattern making. And it starts with a 3D prototype and concludes with 2D patterns that are ready to cut and ready for costing. Scan to pattern is used in a variety of industries for any part that has a fabricated cover, such as furniture, automotive interiors, automotive exteriors, motorcycle seats, HVAC systems, and body parts, just to name a few. Of course, we're not limited to these examples. Scan to pattern can be used for any geometry, both rigid and semi-rigid surfaces, and any surface complexity. So what's new in scan to pattern? Well, we have a new updated scanner from Peel. The scanner has advantages in that it's lighter and it has an easier form factor. It's updated with new capabilities to scan black and shiny surfaces. And it's been updated to increase the effectiveness when scanning in challenging light conditions. There are also new automation features from ExactFlat that streamline pattern making, such as automated notch change and seam allowance profiles that will be released this summer. These features will save even more time when completing pattern making projects. Next, let's talk about the scan to pattern workflow. This we can talk about in 4 parts. The first part is to scan your part, which has 3 simple steps. Number 1, you set up your scanner. You can set your scanner up in any place where it is convenient, you have enough light, and you have access to your part. Next, you have to set up your physical part and apply targets. The targets help the scanner to pick up the reference geometry in a more reliable way. For this, you have to position the scanner in an appropriate scanning context. And lastly, you scan your part. You want to get full coverage, but not overscan. Ideally, you want to be about 30 centimeters away from your part. You want to rotate your hand slightly in a circular motion, and you want to constantly be moving the area of scanning to ensure you're not over scanning, but also spending enough time to sufficiently scan the part thoroughly so that there are no holes. We're going to pause here, and I'm going to hand the conversation over to my colleague Gonzalo, who is an application engineer with ExactFlat. And Gonzalo is going to take you through the process of processing your scan.
Awesome.
Hello, everyone. Okay, so can everybody see my screen right now?
Yes.
Right on. Okay, so what we're seeing here is the scan that my colleague Mark just did on this car seat. So the UI that you're seeing right now is the UI of the Peel CAD software that comes bundled with the Peel scanner. So if you take a look at the scan, it comes out raw from the scanner and will have all the features that were there present in that car seat. So in order to be able to work with this with ExactFlat, we'll need to process the scan with the Peel.cat software, and that will give us the final scan, I would say, that we could use with ExactFlat software that will be fully compatible with our workflow. So the Peel.cat system has all the tools and features that we need to do this in a fast and reliable way. So first of all, I'll start by creating a plane with a plane tool. And this plane will use the object's midplane, detect that symmetry plane. So that way, by creating these reference planes, we'll be able to align our seat with a 3D space. There we go. We can also create an R-plane using the sit button to create an XY plane. Once our planes are created, we can use the alignment features that we got available in the Peel software to force our planes to become the YZ planes and the XY plane as well. So this way, we can now have our seat perfectly aligned with the X, Y, and Z axis in the scene. I'm just going to hit the OK button to confirm. So once that this is done, we can start by smoothing our surface. So we're going to remove all the features that we got from the scan, like folds or wrinkles or some stitching artifacts, with the ExactFlat smoothing tools. So in order to do this, I'm going to go to the smoothing tool over here, and I'm going to smooth out my mesh. And these current settings help a lot, but to remove all the undesired artifacts that we will have in our seed.
This is like the settings that you found that work best with the materials of, a seat like this.
Yes, these are the usual settings that I tend to use. So you can see that now this has smoothed out the surfaces a lot. So I'm just going to hit the K button to confirm. And now I can keep on smoothing out the surfaces and remove the additional artifacts that were not removed with the smoothing tool by using the sandpaper tool. This one allows us to manually choose which features we want to sand over. So if I just click and drag my mouse over these areas, that will remove all those features, and so on. We'll also use the Peel CAD selection tools to select and remove all the features that should not be part of our flat patterns. So for example, all these plastic and hardware geometry should be removed. Then we will use the fill hole tools to fill in the different holes that we have here. So if I go to the fill holes tool, this will allow me to fill in these major sized holes. We can see now that when using the holes tool, this tells me how many holes I have in the geometry. And this large number that we have here, that shows up because we have very tiny holes in the mesh. So if we want to get rid of those, we could use the Peel Clean Mesh tool. This will find all sorts of artifacts that we can have in our mesh and do a more automated cleanup of the model.
Yeah, I really like this tool myself too. So this one's great because it'll even tell you how many triangles of the surface are being affected by each item. So for example, they're under isolated patches, it says 649, I believe. But after the clean tool is done, everything goes down to 0, as long as you have enough iterations in there, and then I like it a lot because this is a lot of cleanup all at once.
That's it. So I'm just going to hit the K button to confirm. And now we can see that that has filled in lots of the tiny holes that we had in the geometry. Then we can keep on using the fill holes tool, for example, to fill in the partial holes that we have here as well, such as this one down below. And then we can use tools like the edit boundary tool, which will allow us to create a continuous and tense edge at the boundary of our geometry.
So it's,
we can adjust.
Sorry, Gonzalo, go ahead.
Yeah, we can adjust the tension to define how tense we want this part of the seed to be, and improves the quality of the boundary, making the file compatible with our flat patterns and the flattening workflow, basically.
So just one comment for the audience out there. You will probably hear of a lot of different scanning companies and a lot of different scanners. We've gone through the process of evaluating the different technologies and feel that the offering from Peel is the best solution for pattern making. And what Gonzalo is doing right now, by processing this scan in such a way that the edges are all crisp and clean and the surfaces are all smooth and the holes are filled in, this is what you want from your source model. The source model has to be perfect. You're pattern makers, and pattern makers demand a certain amount of precision if they are to make proper patterns. This model here is to represent the physical prototype, and the digital processes that follow are to represent the pattern making processes. This first initial step that Gonzalo was going through is to clean the scan and remove the various artifacts such as holes or such as surface irregularities or even edge irregularities. So just I want you to keep that in mind, that this tool set is unique to Creaform and Peel. If you were to do this in a different way, you're looking at 10 to 12 times more time. It can be done, but it's slow and you need advanced skills. So these tools specifically that we're seeing right now are a very compelling reason and basis for choosing the Peel tool set overall. And I would encourage you guys, if you have questions about that, to satisfy yourself that this is the right tool set for your workflow. But from our perspective, these tools right now to clean up the edges, the surfaces, and the holes, these are critical tools that you must have. And you want two things. You want accuracy and you want to be able to do it quickly and efficiency. Gonzalo, I'm going to hand it back to you now.
Right on. So now that our seed has been cleaned up, here I got a smoother version of that seed with some features removed. We'll proceed to make some cuts in the geometry. So I can follow the actual seam locations that I had originally in that seed to actually find the boundaries of my flat patterns and cut them as they should be. So if I go to the Cut Mesh by Curve tool, this will allow me to make cuts to the pieces. So I can simply draw on the geometry and define my seam locations. As Ethan just said, this is a feature that you will not find in any other mesh processing software of any other scanner company. This feature is quite unique, and in this case is crucial for our workflow because this way we can easily define the shapes for patterns so we can send them to ExactFlat for flattening.
So in
So
this
this
case,
way,
you're doing like just every little section, every patch, and I notice you're doing little blue dots on the corners, and then wherever you're curving, you continue with the little red dots.
that's correct. So when we double click, we create one of those blue dots. Those will allow us to create sharp corners. We can also create new dots along the way like this, and we can use them to modify the shape of the curves. So once we're done, we can just hit the apply button, and that will split up the model. Oh, there we go. And this will allow us to split up our geometry and create all those parent pieces. So in this case, I'm just going to skip over to a version of the seed which has been cut out already. And let's just show seed one as well. So in this case, the whole seed has been cut out into all the parent pieces that we need to flatten. We can also split our seed in half and work with one half and then just mirror everything just to work a little bit faster. So once all this is done, we can take our pieces, select them, and combine them together. In this case, we can create a backrest group. And once it's done, we'll have this backrest combined group, which we can export to ExactFlat. So right now, I'm going to switch over to the Rhino window, the Rhino UI. So once these are exported, basically, we'll be able to bring them in to a different software. In this case, we've got that same seed, which has been cleaned up. And this has now been imported into Rhino. So the ExactFlat software works as a plugin that's embedded in Rhino. We'll use the Rhino UI to navigate the model, rotate and move parts around, and we'll use the ExactFlat commands to create the flat patterns and process them and add features to them to export them and send them to a cutting machine. So what we're seeing here is that seat, and the reason why you see this dark color in it is because it has a bunch of mesh wires, and this is because it has a very it is a very high density mesh, right? So we have lots of vertices and polygons on this mesh, which are just natural. They come out of the scanner due to the precision of the scanner itself. But what we'll do as the first stage of this flattening process is to actually rebuild this mesh into a mesh that we can use to create our flat patterns that's compatible with our workflow. So I'm going to go to the ExactFlat mesh tools on top, and I'm going to select the ExactFlat adaptive remesher tool. In order to organize my workflow, I'm just going to create a new layer to do this, and I'm going to call it adaptive remesher. And this way I can keep a backup of the original layer that I had, and I can work on the new one. So I'm going to select the ExactFlat adaptive remesher command, select my geometry, and that will bring in a menu, there we go, where we can set up our tolerances. In this case, I'm just going to use 7 units of tolerance. I know that this values work very well with this model, so I'm just going to hit the start button to confirm it. And we'll see now that we had an initial vertices count for each piece that's sitting around 10,000 to up to 40,000 vertices or more. So what this will do is that it will retopologize the mesh, reduce the amount of vertices and polygons that we had initially, and it will also stitch together all the different vertices at the mesh boundaries, so that this creates a mesh that can be used by our software to create the flat pattern. So let's just wait for a couple of seconds until this processes our meshes.
So right now, what we're looking at is all the triangle numbers are decreasing, and then it's ensuring that the seams are still going to be in line with each other, right? So there's no space between anything.
Yes, exactly. So once we got our mesh, we'll be able to see that in play. Right now what's happening is that it is linking the pieces together. It is basically understanding how the pieces are joined to each other. There we go. So this now creates a mesh where all the vertices from within each piece are matching properly. So this allows our software to detect the seam lines between the pieces and will allow us to use different features that work with this link, such as, for example, a find tool that will allow us to align the pieces together and find what goes where, and other tools such as notch tags or landmarks. So once that this is done, I can just hit the OK button to confirm. And now, at this stage, I'll decide whether if I want the outer face of the fabric here of the seat to be facing up when flattened, or if I want the inner face of the mesh to be facing up when flattened. So if I just select my meshes over here and I run the dir command in Rhino, this command shows me that the mesh normals are pointing downwards. So if I want, for example, the inner face of the fabric to be facing up, I should leave it like that. The reason why I would want to do this, for example, is that if I send this to a cutting machine, and let's say that my cutting machine has a pen tool or a drawing head, it can, for example, add some annotations such as application instructions or tags on our pieces. And let's say that if we want to do that, you will not want this tags to be drawn on the visible side of the fabric. So in that case, you may want the inner face of the fabric to be facing up, just to draw on what it will be hidden on the seat. So if I just want the outer face of the fabric to be flattened and facing up instead, I can just simply flip my normals and just do it like that. So if I just select every single mesh, we'll see that every single mesh now is facing outwards. And I'll just move forward with the flattening process. So I'm going to go to the flattener command over here in the ExactFlat toolbar, select my meshes, hit enter, and this will create two new layers. One will contain an ExactFlat model, and the other one is going to contain all the ExactFlat patterns. I can select my patterns and move them aside. And if I switch over to the top view, now we can see a preview of our flat patterns. What I mean by preview is that right now, at this very first stage of the flattening process, we are taking our pieces and dropping them on the ground or on the table. These are just very raw projections of the patterns that we want to create. So at this current stage of the process, our patterns, since they are being dropped on the ground or on the table, they will have like folds or wrinkles, and we'll want to remove these folds or wrinkles by extending those meshes on the ground. So in order to do that, we can run the ExactFlat pre-flattener tools. So I'm going to select the Smart Fracture command. This command will extend my pieces on the ground or on the table. This will still not give me my end final production ready patterns yet, but it will prepare my flat patterns for the optimization process that will come afterwards. So I'll just click once per piece. And that will do it. So now that my pieces are fully extended on the working table, I can then move forward and go to the second stage flattener command, which is the optimizer command over here. I'm going to select my pieces and hit enter to confirm. And this will bring in this menu that's going to show me all the flat patterns on this list. And if I go to this browser here, this will allow me to choose a material from our ExactFlat material library. So when choosing a material, this will allow us to use the real material's mechanical properties when calculating the shapes of the flat patterns. So the material that we choose here is going to be, it's going to affect the shape of the flat patterns. If the material that you're looking for is not within this list, we do have an agreement with a lab in the US where you can send a sample of this material and it can be tested. So within 5 to 7 business days, you'll be able to add your own specific materials to your material library if needed. That has a cost of around $50 per material sample, so it's really cheap. And that way, you'll be able to just simply add your own materials. Nevertheless, I would say that most of our customers get away with it by using the materials that we already have in the list. I'm going to go for laminate material for car seats in this case. I'm going to choose a linear isotropic model metric. These different model metrics are meant to tell the software how the material is supposed to behave. So when working with more complex materials like, let's say, a carbon fiber or a woven material, then we can choose a non-isotropic model like this one that we have here. But in this case, this will simplify everything. So I'm just going to go for a linear isotropic model, which will work very well for something like a laminar material for car seats. This optimization window will show us the progress while our parent pieces are being optimized. So right now, the software is walking the vertices, the patterns, to give us the final production ready patterns. So this will give us the best possible fitting patterns with the lowest amounts of strain and sag. So you'll notice that right now, as the optimizer processes our pieces, just hit the OK button to confirm that, we'll see that the shape and color of each one of the parent pieces has changed. So now that we see our patterns, we see a change in their color, right? So with a white color, ExactFlat is going to show us that we have no strain whatsoever in that area. Cyan will mean that we have a 5% level of strain, green 10%, yellow 50%, and red 20% of strain or more. And if you happen to see any black shadows in some areas like that, that's going to indicate that we have some sag there. Basically, the material is going to be compressed instead of being stretched. So this will let us preview how the material will behave when wrapping it into this specific seam configuration. So at this point, we could decide if these seams are properly placed or if we want to make some changes and modify our seam placement, which can be done by going back to the Peel software and moving our seams, or we could also use some of the ExactFlat cutting tools to add additional cuts if needed. So now that we have our pieces here, we can use the ExactFlat Find tool to find our neighboring pieces. So first, let me just simply rotate this piece, and then I can use the Find tool in ExactFlat to find our neighboring patterns. The reason why ExactFlat can do this is because of the adaptive remission process that we ran before, which aligns the vertices together and keeps that relationship in place. So I can just easily find what goes where and organize my layout, and so on.
Here you're clicking kind of like on the edges to bring in what's next to it.
That's correct.
Yeah, the process that makes ExactFlat unique here is that all of the locations of those vertices, these are the intersecting points on the triangular polygons, those have been indexed from 3D. And we maintain that indexing through to the 2D process. And even as the mesh elements are being redrawn and potentially the pattern geometries may be cut later on, all those locations are indexed. So we can automate this process of laying out the pattern pieces and easily find them so that you can visualize the sewing orientation. This will also be a huge time-saving factor when it comes to applying seam allowances and notches, because as you'll see very shortly when Gonzalo shows you, when you apply a seam allowance to one edge, it is automatically applied to the other edge. And the same thing for notches or a chain of notches or that type of thing. So your subsequent 2D pattern making processes will be greatly enhanced. In addition, because you don't have to walk the patterns to make sure that the edges align perfectly and the notches align perfectly, you're going to have less errors, substantially less errors. We have some customers who, they would do a boat canvas, boat top, for example. There'd be 70, 80, 90 pieces in their project, and that could be a lot. In fact, we have some clients that make decorative balloons for, say, the Macy's parade, for Disney, for all kinds of applications. These are hot air balloons that may have the head of Darth Vader or the Disney castle or something like that. Those would have several hundred pieces, and the sorting out of those pieces after the flattening process is not a trivial exercise. So this tool has come directly from feedback from users to help them make it much easier, but the utility goes beyond just being efficient. It really reduces errors almost to zero. Gonzalo, back to you.
Right on. So now I'm going to start adding some post-processing features to our pattern pieces. As I said before, one thing we could do is that we could add cut lines, for example, to see how that could impact our pattern pieces. Now we see that on this piece, we got a lot of sag here, which will indicate that we may find some wrinkles in that zone. So for example, if I wanted to try out, let's say, to add a seam that goes across that piece like this, that will cut out the piece in two. So if I now reoptimize this parent piece, this will allow me to see how that affects the shape of the patterns in real time. So if I now run the optimizer again, now we'll see that the shape of these patterns has changed, but their colors have changed as well, as we can compare the piece on the left with the one on the right side. And this one has reused all the sag that I had in it. So if I want to erase that cut or join the pieces back together, I can easily do that. And then I can just simply restore the mesh topology by removing those additional vertices that we're adding during the cutting process. Then we can just simply re-optimize that parent piece quickly. And it'll restart back to what it was before. Then we can take a look at other features such as, for example, the piece tag tools. The piece tags will allow us to name our pieces or add labels to them. So for example, I could call this, let's say, seat. And then I can just simply tag the pieces where I could call it backrest, headrest, and so on, right? This will automatically number the pieces as well. We could also add other tools such as, for example, notch tags. In the upcoming version of ExactFlat, we'll have a brand new notching tool, which will allow us to choose between different notch templates. We added a wide variety of notches. So we can choose between castle notches, check notches, crescent, slit type notches, C notches, U or V notches. These are very commonly used notch types that are used across many fields in the industry. So for example, in this case, I'm going to go for a 1/4 inch V-type notch. And if I add a notch now, when adding a notch, you'll notice that those notches are being added to both neighboring pieces at the same time at the exact same location. So this will allow you to sew your pieces together and to properly follow that seam and to avoid having any discrepancies at the edge length when you're sewing it. Other tool that we are adding or feature is the ability to add a notch chain instead. So for example, I could add notch slits instead. And right now, if I just hit the new button, this will allow me to add this slit notches, but it will add a bunch of notches automatically and it will space them evenly as well. So if I go to the chain properties over here, I can add more notches and so on. And I could just simply repeat the process with the notches on the neighboring pieces as well. So then we can take a look at our grain line tool. For example, if you are working with a woven material that has a specific grain orientation, you can use the grain line tool to mark that orientation on the pattern piece. This will create a straight line that will go to a specific layer with a specific layer name and color in the final DXF file that we create when we send this to a cutting machine. This way, if your cutting machine has a nesting engine, it will be able to pick up this grain line and use it as a reference to rotate the pieces automatically so that the grain lines become adjacent to the x-axis of the cutter and so that your pieces become aligned with the grain of your fabric. When adding a grain line, we can also use additional features to, for example, artificially increase the strain or parent piece. So I could re-optimize this parent piece now with the same material and with the added settings that I just set up. This will artificially shrink the piece. And this way you'll have to stretch it more when wrapping this material. And this tool tends to work very well when working with, let's say, very elastic materials where you want to get a tighter fit. So you can customize your pieces as well. And you can see how the strain analysis actually shows that increase in that strain across that piece. Then we have other tools, such as, for example, the trace tool, which will allow us to transfer any kind of vector graphics or vector information from the 3D model to the flat patterns. So for example, let's say that you have something like a Velcro mark or a zipper that you want to mark. You could just simply draw a vector curve on that piece, like that. And if you want to transfer this curve to the flat patterns, we could just simply use the trace tool over here, select our curve, our piece, and that will transfer that piece. It'll transfer that curve to our flat pattern over there. So we could use this for adding snaps, Velcro marks, or any kind of features that we want to mark. We could also use points as well, or circles if we want to, for example, mark the location of a hole somewhere as well. Just like that. So once we have added all of our features, the very last thing that we'll add to our pieces are our seam allowances. So if I go to our ExactFlat global settings, I just set up my seam allowances to 15 millimeters in this case. Let's just apply that. And if I go to my Parameters tab and hit the Restore button, this will restore this default settings to every single pattern. So let's just zoom in and see how that now creates those seam allowances in our pieces. Well, let's go to our notch tools to restore them. There we go. So now that we added the seam allowance to every single piece, this bleed or additional material to sew our pieces together, we could also customize that seam allowance width per edge as well. So for example, let's say that in this case, we want to have a larger seam allowance here on this piece. So if we go to the set tool, this is going to let me set up my seam allowances locally per edge. So I can just simply increase the seam allowance on that specific edge or on this one as well, and so on. We can play around with the different settings that we have across this menu, such as, for example, adding a specific angle here at a corner. So instead of extending those until they meet, we could just simply change that to a 60-degree angle, a 45-degree angle, or use an angle so that when folding this against the parent piece, this line should become adjacent to the opposite edge, and so on, or simply change the geometry profile to a straight line instead of a perfect offset. In this case, we can just simply set it back to what it was. And we can use the settings to just, there we go, leave it there, and export our parent pieces. So to finish up with our patterns, we're just going to export them as a DXF file. So if I go to the ExactFlat export command, this will bring an export profile selection menu. And this way we can select between different export profiles, which will assign specific layer names and colors to every single feature that we just added. This is also going to define the geometry type that we use, either if we're using splines, lines, polylines, arcs, and so on, or if we're grouping our pieces as CAD blocks or not. So all these settings are going to allow us to create a file that's fully compatible with any cutting machine. So we can customize all of our export profiles by going to our export profile editor over here. So we can just simply create a new profile from scratch if we need to, or go to an existing profile, create a copy of it, and then rename a couple of layers, change the profile name, rename a layer, change its color, and so on. So we can also decide which feature should be exported or not. In this case, let's just close this and export our pieces. So right now I'm just going to go for, let's say, this Gerber Cutworks profile, and I'm going to export my parent pieces. We can choose between the EXF, PDF, and 3DM file formats. In this case, I'm just going to stay with the EXF. And give me just one moment. I'm going to open up the exported file. There you go. So this is what the final file would look like with all the different notches that we added, right? All the tags in our pieces. Each one of the pieces is going to be a CAD block in this case, which means that it will basically group all the features that it has in it together. And this makes it compatible with any nesting engine that you may have. If you need to edit this CAD block or the geometry for any kind of reason, this is just simply a vector file. So if you, for example, open this up with any 2D CAD viewer, in this case in Rhino, I can double click at the geometry and this will show me the boundaries, and everything is just simply a vector polyline because of the profile that I chose. We can see that we got all of our features there, and also we'll see a grain line for each one of the pieces, which will be horizontally oriented by default. So in this case, since I changed the grain line orientation, it is different, but for the other pieces, it will be horizontal, though we could just simply hide that grain line or disable it from export if we don't want it. So that will be it. This is the final result, and now this is just ready to send to a neat cutting machine to cut out our patterns and sew them and create a upholstered seat. So now we'll move on to a Q&A section, right? So I'm just going to mute myself and let Gabriel continue. Gabriel, you're muted.
Oh, thank
Gabrielle,
you. Sorry about that.
Gabrielle, there's a question here for you.
Yeah.
This is a question. It says Peel 3D does not use a spray in the video, and they have a Peel 2 CAD program in which they use a scanning spray. So can you talk about the improvements in the Peel 3 or the new version of the Peel scanner versus the Peel 2, and specifically address surfaces that are black and whether or not they need spray?
Absolutely, yeah. So the Peel 3 has improved a lot compared to the Peel 2. Peel 2 is a great scanner still. We no longer have any more of those on our website available, but the Peel 3 is much faster in comparison to the Peel 2, to the previous generation. The scanning, as far as like more shinier materials, it is able to do shinier things. I'm not going to say that it can scan like absolutely like mirror image type of chrome, but I have been able to scan some shinier metals, so I've been pleasantly surprised with what it can do there. And then as far as that black seat, yep, we can absolutely scan that without any spray at all. That black leather that Mark was scanning in the video worked just fine, no problem.
Okay, and there's a question about cost as well. Maybe Gabrielle, you can. Well, Mark, are you there?
Yep. Yes, I'm here, Eaton.
Mark, can you just talk about the cost of the bundle with ExactFlat and Peel, and then Gabrielle, you can talk about Peel, and then Mark, you can talk about ExactFlat.
Yeah, sure, absolutely, Eaton. So the bundle price for ExactFlat and the Peel 3 scanner, we're running a promotion where we've reduced the price down to $16,495 US. That includes the Peel 3 scanner, the Peel 3 CAD software, ExactFlat, Rhino, and we also provide 4 hours of online training, which we'll go through. Gonzalo will go through the ExactFlat product as well as the scanning software that comes with the Peel 3 scanner.
And Mark, for people who already have Rhino, is there they don't need Rhino installed? Is there a different price for those people?
If they don't need Rhino installed, Eaton, they can take another $1,000 off that price of $16,495, bringing the price down to $15,495 US.
Okay. All right. And Gabrielle, there was a question that we received the other day. It's not specifically in here, but I just want to make sure that we educate the audience that the Peel scanner and the software that Gonzalo was demonstrating, they come as a package, correct?
Yes, when you purchase the through ExactFlat with the ExactFlat and the Peel scanner, you can do the whole package together. Is that the question?
No, I just want to make sure that the software that Gonzalo was showing to clean up the scan, that is included in your purchase of a Peel scanner, correct?
So there are 3 different layers to what you can buy on our Peel website. If you only need an STL or OBJ, no, special cleanup tools like what Gonzalo was using, then that would just be the scanner on its own. Then next level is what Gonzalo was showing. That's like the bundle of the scanner with the Peel.CAD software. That allows you to fill holes partially or fully. You can clean up those edges with the edit boundary. You can separate each piece by the curves that you create. So that's very important if you're going to be doing 3D to 2D. You at least, at the very least, have to get the Peel3.CAD option. That's like a bundle. And then for people that are also doing more CAD work and they want to be able to do sketching and CAD development within the CAD software, there's a third option, and that was called the Peel 3 Pro. Peel3.CAD. So each one goes up a little bit in price, and then each one is, just more advanced than the previous version.
Okay, thank you. And Mark, can you just comment on which version that Gabrielle has just outlined there, or Gonzalo, which is appropriate with the tool set, the complete tool set that you need for creating patterns from a scanned object?
I can take that question. So, Eaton, the bundle that we're offering includes the Peel3 CAD software along with the scanner. So that's got everything the person would need to do exactly what Gonzalo's done in the demonstration. So going right from the scan, cleaning up the scan, and then creating the patterns in ExactFlat and exporting out to your CNC cutter or your plotter.
Okay, all right. So more questions, and forgive me if I don't get them in order because the questions are coming in here. I'm just going to start at the top of the thread. So if you already have a 3D scanner but really like the tools from 3D, it's very similar to VX. Gabrielle, can you comment on that?
Yeah, so the Peel3.CAD Pro, sorry, the Peel.CAD Pro software that we just released in late March of this year, 2025, that one is very, very similar to VX Model. You can even import STLs. So if you happen to have something from a different scanner, you can import the STL from your other scanner, and we can work with the Peel.CAD Pro software there. Of course, you have to buy it with the scanner. So yeah, and then other things too is you have a lot of like cleanup tools there. You have a lot of ability to compare your scan to your CADs while you're developing your CAD work there too.
Yeah, and I'll just comment for everybody just so that they're absolutely clear on this. You have a lot of choices for scanners in the marketplace. Scanners have evolved a lot and they're capable. The big advantage that you have with Peel is the tool sets that are available for post scanning. They are not nice to have. In our opinion, they're critical. So you have a number of jobs to do once you've got a scan. The first job is that you have to clean it up. You have to get rid of holes. You have to straighten the edges out, get rid of the jagged parts. And the third thing is you have to smooth surfaces and even take out elements that are not part of your desired pattern making geometry. The last tool set is the tool for cutting pattern patches. And while this is possible in other technologies, and we have tried it in other technologies, it's not a viable commercial solution. You will spend 10 times the time and you will have to have very, very advanced CAD skills that we don't see are very common in the marketplace. So the Peel offering is, we think, very reasonably priced, very robust in terms of its tools, and very compatible for preparing your scans for pattern making with ExactFlat. So if anybody wants to know more about these critical things that are in the middle of your workflow, remember, you've got 3 steps. Scan your part, you convert your part to CAD, and that includes all the cleanup that you have to do. And then the last part with ExactFlat is you convert to 2D and you put all your pattern features and all that kind of stuff in place. That second part is the most problematic part for a lot of people, and the tool set from Peel is there. And we're not just saying that because we're on this webinar. We're saying that because we've tried it. We've tried it and we've seen it and we've come to our conclusions about it. So that question from Dylan, thank you for the question, Dylan. And if you need to know more about that, you can reach out to us, right? Okay, so we have some, and again, I'm going to try and get to them all, but just in the right order here. So there's a question about clarity. The 16495 package includes which Peel 3 CAD or Peel 3 Pro? Mark, can you just speak to that again?
Yes, so the bundle that we're offering comes with the Peel3 CAD software.
Right, and that also includes Rhino and includes ExactFlat and everything that you need for pattern making, correct?
That's absolutely, Eaton. And again, if they purchase the scanner bundle, they would receive 4 hours of training with that.
Right, okay. Okay, so now we have a question from Kevin here, and he said he wants to add an image to a seat as a sticker, and could he add that image using Rhino or Peel CAD, and would ExactFlat be able to distort the image to the flat pattern? So this is a good question, and the answer is very simple. ExactFlat can flatten graphics perfectly well. It depends on the resolution of your source graphic. So while the Peel scanner is great for capturing geometry, it's not going to give you graphic quality that is similar to what you'd produce when you create vector graphic art. So that's just one thing to keep in mind. What people tend to do is they will use the scanned graphic image as reference locations, and then they might use a product like Substance Painter to paint that graphic onto the 3D form, and then ExactFlat can flatten it out. So I'll give you a number of possible applications here. So suppose you wanted to make decals for a race car. You could scan the geometry of the race car, and then you could paint the decals on there. And when you flatten, say, the quarter panel or the hood or the door panel of that race car, you would flatten the graphic out, and then you could just print the graphic on a printer and then place it in the location you want on that car. That would be the same thing for any kind of graphic, whether it be a race car, bicycles, helmets, or whatever it might be. That product is called Monarch, and it's available from ExactFlat as well. And if you want to know more about that, then please reach out to us, and Gonzalo and Mark can certainly help you with that. So Vic, we've answered yours. Kevin, we've answered yours. I think Dylan, we got yours. This is another question from Dylan. Yep, we have that too. Let me keep going down. Okay, question from Dwayne. What's the accuracy of the scanner for large upholstery, such as 8-foot benches? How about scanning whole boats or enclosures? So let's just go with the accuracy question first. So we have recommendations for accuracy. Maybe Gonzalo or Mark, you can talk about what resolution is optimal for scanning small or large objects for pattern making. If you guys can just comment on that, please.
Sure. So actually, when working with ExactFlat, we don't really need an extremely high resolution for just scanning the geometry. The reason being is that we don't really want to overload the software with way too many vertices. So depending on the size of the object, we'll basically choose our resolution settings based off on that. So let's say that if you're flattening something the size of a helmet or just something that has a very small surface area, in that case, you may want to use a resolution of around 1 millimeter. We don't really need anything larger than any polygon size to be smaller than that. For something of the size of a car seat, for example, we could use something like a 1.5 millimeter resolution. And for something of the size of, let's say, a vehicle, a car bumper, we could go for like 2 millimeters. So since the surface area to cover is larger, we will set a resolution a little bit lower in that sense. So basically larger than millimeters.
There's also some other factors to take into account other than your actual part that you're scanning. So for example, the stretchiness of your material, that's a factor. If you look at a paint protection film that would be applied to the outside of a car, that can have a very semi-rigid film that doesn't stretch or a very stretchy film. In the case of a stretchy film, they want the part to be smaller, so your resolution would be appropriate for that. If you have something that you're scanning that has to fit into very tight tolerance, then you might increase the resolution. The good news for you as a potential buyer of the Peel scanner is that you can set your resolution and you can go down to a small detail, or you can keep it at a higher detail for faster, more efficient things. So, for example, for 8-foot benches, it's not the resolution is more than ample. In fact, the scanning capabilities these days for pattern making are more than sufficient for accurate pattern making and sort of commercial sewing operations. If you're scanning for inspection, for cracks, for things like that, that's a whole different area, and you would need your scanner to be able to accommodate those types of things. So scanning whole boats or enclosures, it depends on what you're doing here, and I would say that you should reach out to us and we can talk more about your specific needs there. ExactFlat is used extensively in the marine industry, and it's one of the leading pattern making tool sets. But without knowing a little bit more about what you're trying to do, Dwayne, I think the best way to answer that question is just reach out to Mark and Gonzalo and team, and they'd be happy to talk more about it. We have a lot of experience in that category.
And just so that everybody knows, I'll put the slide up. We're not done yet, but I'm putting the slide up just so that you have access to Mark's email address and also his phone number there, in case you do want to reach out.
Okay, so there's a question from Aldrin, and the question is, we're still new to 3D scanning and we're learning all the stuff. We are in the aftermarket marine industry. How well or hard is it to work with ripped seats? So I will say that this is an application that is perfectly suited for the scanning and ExactFlat combination. Let me just say that right away. We have customers doing this. They're actually getting commercial results, and this is something that we can certainly accommodate. Now, rip seats, the historical way that people who are doing aftermarket marine on a hand patterning basis, they'd unstitch the seat fabric, they'd lay it down and trace it out. If the seats are ripped, they would just interpolate that geometry with a pencil and try and get the perimeter of the pattern that way. If the seat bun or the underlying foam is intact, it's very easy to scan the seat and to get your geometry that way, and then you could create your new patterns using the workflow that Gonzalo just showed you here. So it is not a difficult process, although it is not you do have to take care to do the work with precision. So we have a lot of experience with this. The training programs that Gonzalo has put together, they can show you how to process your files, work with ExactFlat to get your patterns to fit perfectly every time. The underlying object that you're scanning is what will be used to generate your patterns. So if you want a different set of patterns that doesn't conform to that underlying object, you're going to have a mismatch. Just keep in mind, the scanner will pick up exactly what it sees, and ExactFlat will convert exactly what is in that 3D model prototype. So Aldrin, I hope that's helpful for you. We have a lot of customers in Australia doing aftermarket car seat covers, marine. So if this is something that you're interested in, reach out to the team and they can help you. Okay, I hope I'm not missing anything here. Let me just scroll the list again.
I'd like to answer one question here that I have here.
Sure.
So from Dustin, we have, for use in the marine canvas world, what's the total range for scanning? Say we had a top that is 14 feet long, 8 feet wide, 6 feet tall. Can we navigate around this with the scanner? You could potentially do this. You would have to have you would have to make sure that you'd have to be placing targets all over the part, since it is mostly flat and mostly large and wide. So these targets, you'd be placing them around like every 4 inches or so. So you could still do it. It would just take a long time to place those targets down. But then also you need to make sure you have a very strong and powerful computer. So on our website, we do have minimum specifications of laptop that we recommend for 3D scanning. But if you're scanning something as large as this, I would recommend something way more powerful. And just know that there's a chance that you might have to scan and save the different sessions and then merge it all together later on. We also, since Peel 3D is part of the Creoform family, there are some other scanners that are out there that you could reach out and get those instead. For example, there's one called the HandyScan Max. And that one is really meant for very large parts like what you're mentioning here, because you wouldn't have to put targets absolutely everywhere, but it does come at a higher price point. So it's one of those things where it really depends on whether you want to save the time on that sense, or if you have the budget to be able to do the HandyScan Max. So that's the answer for Dustin. Thank you, Dustin.
Okay, I'm not sure I understand this question entirely, Dylan, but it's probably for you, Gabrielle. With the peel, how much volume can the peel take at once?
Okay.
I'm assuming volume might mean surface area. I don't know. Maybe give it a shot there.
Yeah, that's kind of the question I just answered a little bit, in that you, like on our recommended specifications, it says something around 10 feet. You can go past that, but just know that you'll want to be placing targets, and you will have to scan separate pieces and merge them together later, and then you'll have to do it with a probably a more powerful computer as well, from what we have recommended.
There's also a question from Eduardo Gallardo, regarding the 2022 Peel software, if there's an update and the cost of an update. Are
Yeah, I
you
saw that
still?
question. I'm not sure
Yeah.
of the answer on that one, so we'll get back to you via email on that one, Eduardo.
Okay, so Aldrin, another question from Australia. Are there limits for the Peel software in ExactFlat? Is it possible to use it simultaneously with a team member? Well, the answer to that is both software, both products are sold on a per license basis. If you want multi-team member with ExactFlat, you can get network licenses that will allow you to have many installations, but will limit the number of users to the number of licensees. So you can install the product, say, for example, at home, at work, multiple locations at work, in production and costing and that kind of thing. And then it will limit you to the number of licenses that you've paid for. So if you paid for 2 network licenses, you get 2 simultaneous users. Pay for 3, you get 3 simultaneous users. Best thing to do on that one is to reach out to Mark. I'm just going to put that in the chat box here. And then Mark can help you with that question. If you have bigger production environments, we can certainly accommodate that.
We have another question, and it's about accuracy, so I'm pulling up my calculator here. We have Dwayne asking, what is the accuracy of the scanner for large upholstery, such as 8-foot benches? How about scanning whole boats or enclosures? So let's start with the 8-foot question. So if you go also to our website and you go down to the technical specifications section, you'll see that there's like a kind of like a little equation, and so it really depends on how large your object is. So in the case of 8 feet here, and I guess I'll do it over here on the screen so you guys can see it. I'm going to be multiplying, and if we're talking about inches, I'm going to be multiplying 8 feet times 1.2 thou, so that's going to be 0.0012. So that ends up being about 9 thou, maybe about 10 thou, but then there's also plus the 50, so it ends up being so let me just kind of show you what I have here, the little equation, so you have an idea of what I mean. So we're looking at 2 thou plus the 10 thou, so it ends up being about 12 thou for an 8-foot object, and that's if you're placing those targets everywhere.
Okay, there's a question from Caleb Gonzalez, and this is about, it says, could entire cars be scanned at once? Are there demos on this? Does the training include help with how to scan the exterior of a vehicle? So I will tell you, Caleb, that scanning vehicles is a very common use case for the scanner. In fact, the OEM makers of some of the film that is used in the marketplace, they have invested in scanners. In fact, many scanners to scan vehicles so they can make templates. The cars can be scanned. Yes, that's not a problem. You don't necessarily have to scan the whole car because you can mirror the parts. So for example, you could scan, like the left quarter panel, the left door, the left-hand side of the bumper and the left-hand side of the hood, and then you could mirror those parts. You can scan them at once, and then you go through the process that Gonzalo has showed you of sectioning your scan into individual parts so that you can make your templates. This is a very common use case, and if you have questions, I would encourage you to reach out to Mark. Mark is one of the ones who pioneered the use of the scanner in paint protection film, and he knows this category very well, as does Gonzalo. Both of them are really quite experienced in the scanning of vehicle parts. The process certainly, and the training that is included, I believe that Mark said it was 4 hours, which is about 2 hours with ExactFlat and 2 hours with the scanner. And that generally is, depending on your background, that will generally get you going, and within a week or so, you should be able to scan production level parts. But I say that with a caveat, depending on your experience. If you have some CAD experience, it should not be a problem. If this is all brand new, it may take a little bit longer. I hope that answers your question, Caleb.
And then here we have also Dwayne asking, I might have missed it, but what is the cost of the Peel and software alone? I already have ExactFlat and Rhino. Okay, so yeah, we have since you already have ExactFlat and Rhino, you'd either needing the Peel3.CAD or the Peel3Pro.CAD, depending on if you need to create CAD as well. So for the Peel3.CAD, that is currently at the time of this recording, because we're going to be placing this online later. At the time of this recording, it is $8,990 for the Peel3.CAD, and then for the Peel3.CAD Pro, that one is $11,990 USD.
Okay, I don't think we've missed anybody. If we have missed anybody, if you could just put your question in again so it floats to the top, and then we can answer it. And also keep in mind, if there's questions that you do have, you can reach out to Mark. Mark will either direct you to some additional resources, or he'll just give you a call back himself. And okay, looks like the updated ExactFlat mesh is better, leaving less holes in the mesh. So this is if you're looking at the scanned meshes themselves, you have to fill in the holes in the scanning software. Holes are not part of your pattern, so they are holes that are not intended to be part of your pattern should not be part of your pattern. And so those meshes will have to be filled in, and then when they're brought into ExactFlat, what we do is we redraw the mesh, and there's two reasons why we redraw the mesh. We reduce the complexity of the mesh for faster, easier processing. That's one reason. And then the second reason is when ExactFlat converts from 3D to 2D, we don't flatten individual pieces. What we do is we flatten the whole set of meshes together. And when we make a change to one mesh, like this mesh on the right-hand side, we make an equal change to its adjacent piece because we know that these pieces have to align perfectly. And so we redraw the mesh in such a way that we link and associate those pieces together. That makes all of your downstream stuff faster. It makes your visual layout faster, your seam allowances, your notching faster. And we're on the process about a couple of weeks away from automating that to just a couple of buttons, so you don't even have to pick an edge anymore. You can just click once and apply a profile. Now, your question about leaving less holes in the mesh. You want 0 holes in the mesh that are unintended. If you want a specific hole in the mesh, what you can do is you can trace those locations using our marking tool. When the locations are traced onto a 3D part, we will translate that to 2D, and those will become cutouts. So if you're, I see that you're doing covers, Eddie. If you need access patches or holes for cleats, or for holes, access points for antenna or whatever it might be in your boat canvas, then those can be traced on, and then when you go to cut your pieces out, they'll be cutouts, and deliberately put holes in the mesh. But unintended holes, those should be eliminated in the scanning processing, and then once you have that eliminated, ExactFlat will be able to manage the rest of the meshing process such that your pattern making is much faster. I hope that answers your question, Eddie.
So we are out of time. I don't know if we have, there are a lot of questions that we haven't missed or that we haven't answered yet, or maybe we could reach out to you at the end and email you, unless there's any last questions that you might want to answer, last ones at all. Okay, so we do have a lot of questions still available, but we are out of time, so we are going to reach out to you via email, and we'll be able to answer you there. Once again, we are recording this message or this whole webinar, so thank you so much for attending. I appreciate you, Gonzalo, and thank you, Eaton, for joining us today and giving us like the rundown on how everything works from 3D to 2D.
Well, Gabrielle, thank you for sponsoring everything. I thank the participants for coming. Your questions were great. It seems like people have a high interest in becoming more productive. And as a parting point, I would just say reach out to Mark. Mark is happy to help. He gets back to people very quickly. And we will be running some promotions in the month of July as we release new features with ExactFlat. And there'll be some price incentive and some training incentive. So if anyone has an interest, give us reach out to Mark. We're happy to continue the educational dialogue, and the recording will be made available to you as well. So thank you, Gabrielle, and I hope to talk to people soon again. Thanks.
Thank you for having us, and thank you for watching.
Thanks. Bye-bye.
Okay, bye-bye.
Bye.